Hello, good morning, students.
Good morning, sir.
Hello, sir. Good morning.
Good morning, sir.
Good morning.
Morning, sir.
Good morning, sir.
Class. We shall wait for 2 or 3 minutes. Students are entering still. And let us start for today. Last time we were discussing about I think commentaries. Yes. Last time we were discussing about this topic commentaries. These are the introductory formulas for the permutations. We discussed about the permutations and the combination. Permutation means arrangement and combination means selections. These are the few formulas based upon the arrangements. Again, I repeat it. If there are total n objects and you have to arrange r objects, r is less than n, r is less than n, then total number of the arrangements, we write it in this way, PNR is equal to NPR, that is equal to n factorial upon n minus r factorial. If n objects are arranged in circle, it's very important, single line, single word, numerical, that is equal to n minus 1 factorial. Say, there are the 10 students and we make them to sit around a round table. Then how many arrangements are possible? 10 minus 1 is equal to straightforward 9 factorial arrangements. And if R1, R2 and R3 are the different arrangements in the total n objects, say, hello, is it problem? Oh, yes. If R1, R2 and R3 and so on up to Rn are the different arrangements in the total n objects. Say, the example last time we discussed, let there are the 20 students in a class. Some are wearing white shirts, some are wearing red shirts, some are wearing blue shirts. So among the 20, these are the total n objects, R1, R2, R3. They are the different objects. They are the different objects. In such a case, the total number of the arrangements is equal to n factorial divided by R1 factorial, R2 factorial and R3 factorial. And just we just discussed this numerical, it was based on the FQC. Along with, beside these three formulas, sometimes we can calculate the given condition on the tips by using the fundamental principle of the counting. By FQC we say. So students are coming. But fundamental principle of counting means simply we can count the things on the tips without using any of these three formulas. These are the basics. We start with the basic complement arrangement, permutation, then combination. Then we will combine the both topics. Again, I repeat this example. Rather, we discussed it last time. How many license plates can be made if each should have the three letters of English alphabets with letters repeated? There are the two conditions and letters not repeated. Same type of the numerical was in the previous exam. Just you will get the PDF on your WhatsApp today for the this last question paper and the important solutions of the questions. We shall discuss it later on. You will get this PDF. I have sent it to your study center. They will send it to you. See, we have to make the license plate having the three English alphabets. There are the two conditions with letters repeated and letters not repeated. Sometimes these conditions are written. Sometimes these conditions are written. Sometimes it is not written. If it is not written, you can choose any one of the conditions or you can do both the conditions. First condition, when the letters are repeated, we can see the number plates on your bikes, on our cars. Say it is PQR, ABC. These are all the three different English alphabets in which repetition is not allowed. But sometimes you see AA, P, A is repeated. Or you can say B is repeated 3 times. So there are the two conditions, letters are repeated or not repeated. Here it is a rough diagram. These are the three locations of English alphabets. There are total 26 English alphabets. So imagine first letter. For first letter, there are the 26 English alphabets. You can put any one of them here. So you have 26 options. For the first letter, you have the 26 options. Similarly, for the second letter, again you have the 26 options because repetition is allowed. The letter we use here can be used here also. So for the third letter, again there are the 26 alphabets. you can use any one of them. So you have the 26 options. All the three positions you have the 26 and the 26 options. So write it in this way. First letter can be arranged in 26 ways. Second letter also in 26 ways. Third letter also in 26 ways. Why? Because the repetition is allowed. So until the process is complete, we multiply the different situations. So total number of the letters is equal to 26. 26 multiplied 26. That is equal to 17,576. Now what will happen if there is no repetition? If repetition is not allowed. Repetition not allowed means the letter once used here cannot be used in these two positions. Again we draw a rough diagram. No. For the first letter, you have 26 options because there are the 26 English alphabets. One English alphabet is fixed here. The remaining are 25. Now for second letter, you have 25 options. No. One more English alphabet is 6. No. Remaining are the 24. For the third, you have the 24 options. That is the difference between the repetition and the non-repetition. In this case, repetition is not allowed since the letter, the English alphabet used at the first place cannot be used here, and for this, these both cannot be used. By using the fundamental principle of counting, we write it in this way. The first letter can be arranged in 26 ways. Second letter can be arranged in 25 ways. Third letter can be arranged in 24 ways. So the total number of the letters is equal to 26 by 25 by 24. Until the process is completed, multiply the different situations. It is the multiply theorem. Sometimes use the addition theorem also. We shall discuss it into the combinations. This was the numerical we discussed earlier last time. So, see the different condition here. This is the question paper PDF you will get on your WhatsApp. Remember, we have done this. We shall discuss this question later on. This numerical we have done. See, same type of numerical here it is. On edge. How many three-letter words which has vowel in the middle? So, the problem with them is the vowel in the middle position can be formed using the letter of the English alphabet. It was previous question paper which was held in February, I think. The difference here is, no, he fixed the middle letter. Again, there are the three-letter word. Three-letter, first, second, third. Middle letter, he wants only vowel. But see, there is nothing written. Alphabets are repeated or not repeated. I have also sent the many solutions. See, these questions we discussed in the functions. I also sent the solution of this one. You can try this. Let us see. This numerical. You have to make the three-letter word in which the middle letter should be the vowel. Let's see. there are the 26 alphabets, number of vowel 5, so the number of consonants are the 21. You will get the PDF of this all. These are, I think, 10 pages. You will get it. So, case 1. If repetition is allowed, remember the bifurcation is here. Total English alphabets 26, vowels 5, consonants 21. Here the condition was the middle letter should be the vowel. We will start the narrative from here, from the middle, not from the left or the right. Here the middle letter, it has only 5 options. There are the 5 vowels. And see, the repetition is allowed. If means for the middle letter, you have only 5 options. You write here 5. This is a rough diagram. No, if we start the first letter from here, for the first letter, you have 26 options, 26 alphabets. From 26, any letter can be used there because repetition is allowed. It means, see, repetition allowed means the vowel used there can also be used there. Repetition is allowed. So there are 26 options, and for the last letter, also there are the 26 options. There are also 26 options. That is the difference between the previous numerical and the numerical in the exam. In exam, he changed the statement. He fixed the middle letter as a vowel, and we know the vowels are 5. Vowels are 5. No, you can write according to the FPC, the number of ways in which the middle letter can be arranged is equal to 5. We start with the middle letter. Similarly, the number of ways in which the first letter can be arranged is equal to 26. And number of the ways in which the last letter, that is equal to 26. You can write first, write last here, there is no problem. So the total number of the 3 letter words, please control your mics. Mic, I think there's some student has a problem with his mic. That is 5 into 26 into 26, that is equal to 3380. Okay. It is the first condition. No. If we say repetition is not allowed, what will happen? If repetition is not allowed, again we draw the rough diagram, first, middle and the last. Again we start from the middle letter. Because, please, switch off your mics, please. You have only 5 options because there are the only 5 vowels. From the 5 vowels, any one vowel can be written here. So middle position has the 5 options. Now come for the first. So this time you have taken the 21. These are the consonants. Because the repetition is not allowed. It means the vowels used here cannot be used there. If we delete the vowels, it means the remaining are the consonants. So for the first letter, there are the 21 options, and for the last, there are the 21 options of the consonants because one consonant is used there. For the last, it is 20 consonants option. No, the number of ways in which middle letter can be arranged is equal to 5, and the number of ways in which the first letter can be arranged is equal to 21, and the number of ways last letter can be arranged, that is equal to 20.
How is last is become 20? Please elaborate again.
See, there are 26 alphabets, 5 vowels.
Yes.
We have used the vowels here. Now remove the vowels. The remaining are the consonants. Consonants are 21. Consonants are the 21s.
Yes.
Now any one consonant can be put here. So you have 21 options. You have 21 option. Clear? No. The one consonant is used here. Then how many are left now? How many are left? 20.
20.
So for this, there are the 20 options. There are the 20 options. Okay?
Yes.
Because here repetition is not allowed. The consonant written here cannot be written here. But in the above case, English alphabet written here can be written here.
Okay.
That is the difference between both the situations. And simple, if we multiply both, is it 2100? Let's say this numerical I have solved it for you. Set from the set theory A cross B, A cross A. This PDF you will get it. This is from the functions we discussed. Again I solved it. And this numerical we will discuss. Okay? Go ahead, talk again. Let us come to the main topic. This one. Again, see, it is also based upon the fundamental principle of counting. FPC, it is not a formula. It is very basic, school level principle. But mostly you see, we have a numerical in exam, almost in every exam, from the fundamental principle of counting. All we are discussing, they are from the exams. See, how many license plates containing 2 letters followed by 3 digits? Remember the situation? How is the number plate? Let's see, written on our bikes or cars, there are the 2 or 3 English alphabets, then there are the number 5, 6, 7, 8, like this. Here, he also wants the number plate or license plate in the same manner. The first, there should be first 2 letters and then the 3 digits. Remember, first 2 letters, then the 3 digits. Can be formed if repetition is allowed. No, it's written here, repetition is allowed, so we will not discuss the repetition not allowed. Total number of the English alphabet 26, or not 29, by mistake I have written it. It's 26. Okay. Manual, I have to solve them. Sometimes there is mistake. Please make it correction. And the total number of digits 10. When you count the digits, remember 0 is also counted. 0 to 9, they are the 10 digits. The situation is clear. Yeah? It is a rough diagram. It is the rough diagram. It is not compulsory, but it will help you in understanding the condition and the situation, and then express it on your answer sheet. In red pen, we have taken the letters, and in the black pen, we have taken the digits. And requirement is 2 letters and the 3 digits. Condition is repetition is allowed. Repeat the condition. You have the 26 alphabets. First letter, how many options are there? 26. For second letter, how many options are there? Again 26. Why? The repetition is allowed. The problem is here, digits. Why it is problem? Problem is 0. Problem is 0. See, on the right hand side, 085. Is it a 3-digit number? No. It is a 2-digit number. It is a 2-digit number. No, problem is, you cannot write 0 here. Please switch off your mics when you want to ask something. Then you can ask. Otherwise, it will create the trouble from all the others. See, this figure written 085 It is not a 3-digit figure. These are, if we count the rupees, these are only 85 rupees. These are only 85 rupees. Okay. It means for the 3-digit, here you cannot write, forget the dead letters, that portion. No. Now you have to arrange the digits. You cannot write 0 here. If you will write the 0 here, it will become a 2-digit number. It will become a 2-digit number. But he wants a 3-digit number. But he wants a 3-digit number. So you cannot write 0 here. If we delete the 0, then how many digits are there? 9 digits. It means you have 9 options for this 100 place. It is a 100th place. You have only 9 options. Why? 0 cannot be put here. Okay. For 10th place, it is a 10th place. You have the 10 options. So 0 can come here. 0 can be put here. For unit place, again you have the 10 option. Again you have the 10 option. Because the repetition is allowed. Repetition is allowed. This is a low code. Okay. If you will write the 10 here, it will wrong. The digit will become like this. 085, 075, and it will become a 2-digit number. 2-digit number. Okay. So we delete the 0 for the 100th place. For the 100th place. So the total number of the options, we multiply all these situations, 26 by 26 by 9 by 10 by 10, that is equal to this. So don't try to cram the numericals, only try to understand the conditions and the situations. So these are the few ones based upon the fundamental principle of counting. In your booklets, there are many ones you can discuss there. How many different words can be found by using all the letters of the word distinct? Remember, here the condition, all. You have to select all the letters. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. First of all, bifurcate them. Bifurcate them. Here D1, I2, S1, T2, N1 and C1. Total number of the letters, 8. Total number of the letters, 8. How many words can be found by using all the letters? We place S before I, after that, by mixing all these letters. If it's their meaning in English exists or does not exist, we are not concerned with that. We are concerned with only how many words can be formed. See, here the situation is, the total objects are 9, in which these are the R1, R2, R3, R4, R5 and R6 are the different objects, So we use the formula, total number of the words is equal to n factorial divided by R1 factorial, R2 factorial, R3 factorial and so on. N factorial means 8 factorial divided by 1 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial. Always remember 1 factorial is equal to 1 and also 0 factorial is also equal to 1. Then solve it and it is a final answer, that is equal to 10,080. 10,080. This was the condition in which you use all the letters of the word. Word may be anyone distinct, sometimes they give it is equation. These are the important ones. Sometimes they give the word permutation. What is the permutation? So what will happen if we don't use all the letters? That's clear? Awesome. Follow Sina. Okay. The numerical here is how many different words are possible. It's from the same family we discussed. Distinct. I say the in place of the distinct, it may be equation, it may be the permutation. You can try it at home. Using the 6 letters, no, there is a change. In the previous numerical, the requirement was using all the letters. Using all the letters here are using the 6 letters. Then what is the difference between both the conditions? At a time of the word logarithms, of a logarithm. See, there are the 10 letters. There are the 10 letters. From the 10, you have to arrange only 6. You have to arrange only 6. If it was written all the letters, again we would have used the same formula as in the case of the distinct. But in this case, total number of the objects are 10 and we have to arrange the 6 from them. Simple numerical. Then use the simple formula number of the words NPR is equal to 10p6 is equal to 10p6. No, don't count which are the different and which are the same. Simple. 10 factorial divided by 10 minus 6 factorial. Formula n factorial divided by n minus r factorial. Then solve it. It is 151 to 100. If there is all, then you use the formula, which one? N factorial divided by R1, R2, RT, and so on. If the total n, he says by using 9 letters, 8 letters, 7, 6, 5, 4, 3, 2, 1, you will use this formula. You will use this formula. So that is the difference in both the situations. And both the numericals are from the exams. So one numerical I left in between the both. It's also from your exam. But for 2 marks, how many distinct ways is it possible to sit 8 persons at a round table? Simple. You have to make the 8 persons sit around a round table. In the permutation, the formula was n minus 1 factorial ways. In how many ways can we arrange the n objects in a circle? N objects in a circle, that is equal to n minus 1 factorial. Simple. Here, the 8 students have to be arranged in a circle. In how many ways? Simple. 8 minus 1 factorial, that is equal to 7 factorial ways. That is the answer. Expand it, it is this. It's a one-line answer. It is one-line answer. Is clear? Hello?
Yes, sir.
Yes, sir. It's clear.
Yes, sir.
All, rather it's some theoretical, but all these things are the basics. You see, this numerical is from your booklet. Very short answer, but a common situation. In how many ways a garland can be prepared with the 7 unlike flowers? Simple. Often we go to the worship places, we buy the garlands, but the garlands are of the same color. Either they are yellow or they are sometimes roses red. But here the situation is 7 color garland is to be made, and all the flowers are of the different colors, say yellow, red, white, and so on, blue. There are 7 different types of the flowers. How many ways a garland can be prepared? No. There are 7 different types of the flower. Always keep it in mind. Now you see how the shopkeeper, they make the garlands with the needle and the thread. They put the flowers into the thread one by one, one by one. Say he will start with red, blue, white, or he may start with white, or he may start with blue. Okay. So there are a different number of the situations. But one thing is clear. The garland is round. The garland is round. The same condition that we discussed, in how many ways 8 students can be made to sit around a round table. ठीक है, 8 स्टूडेंट को हम गोल चक्कर में कैसे बैठा सकते हैं? That is equal to 8 minus 1 factorial. In the same manner, same condition, in place of the students, there are the flowers. In how many ways the 7 flowers can be sit around a round table? Round table is like a garland. That is equal to simple 7 minus 1 factorial. 7 minus 1 factorial. Now we will ask why it is divided by 2. Now I will explain. First of all the 7 flowers, they are arranged in the circle. So the total number of the arrangements are 7 minus n minus 1, 7 minus 1 factorial. Now see, if the shopkeeper is going to make the garland, see, he can make the garland clockwise, and second option is anti-clockwise. Anti-clockwise. Think over it. Put the red, then white on the right side. It can be done also from the left side. Red, white, blue. So there are the 2 options. Garland can be made. It can be made clockwise as well as anti-clockwise. So we divide it by 2. Otherwise it was a simple numerical. That was like this. Here. 8 persons can sit around a round table. 8 minus 1, 7 factorial. In here, all the question is, you may ask, why in this case there is not clockwise or anti-clockwise? Why there is not? Can someone tell me why we have not divided by 2?
Because all people are different.
Yes, flowers are different, but all persons are same. All are men. They are the same. That is the difference. Okay. And it's an important one. Rather, it's a 2-line answer. Again, it is important one. Now see this numerical on the permutation. concept was also in this exam, previous exams. After this, we will discuss about that. Let's see, what is the situation here? Now, always remember, during the arrangement, when you arrange the things in a straight line, there are two options, left and right. One position is increased, but when you make the circle, left and right connects. Just a minute, please. Give me 1 minute, please. I'm coming. Yes. No. Let us discuss this situation. Suppose there are the 5 married couples. Married couple means 5 men or 5 women. In this case, the count of men and women are same. 5 men and 5 women. But the numerical in your exam, in the February, there was a problem. There were 5 women and 7 men. That was the only difference. And this difference, how the answers changed. First we discuss this basic problem. There are the 5 married couples and they are made to sit about a round table. Again the situation. But the problem is to make them around the round table so that neither 2 men or 2 women sit together. It means 2 men or 2 women, they don't want to sit together. Then what is the solution? We say no. Or they do not want to sit adjacent to each other. We say simple. 1 man, 1 woman. 1 man, 1 woman. Alternative. We sit alternatively, simple one. But how? It is a rough diagram. You can also draw on the answer sheet also. It will help you to understand and to express your solution on the paper. So there are 5 men and 5 women. After this, we shall discuss the count is different. No. It is a round table. Sir. Now from the 2 groups, you call 1 group first. First we call the men. We call them. All men should come and sit in a circle. So 5 men can sit in 5 minus 1 factorial is equal to 4 factorial. Is it clear? Similarly, if someone wants to call the woman, they can write the woman here because count is same. So we have called men to sit around a circle. This one. Say M1, M2, M3, M4, M5. So the formula is n minus 1 factorial for men. Why? Because the circle is made by the men. As the men sit in a circle, leaving one place, say, these are the vacant places, 1, 2, 3, 4, 5. Now we call the women and say, sit in the vacant places. No women, they have already the places 1, 2, 3, 4, 5. They need not to make a circle. Circle is already formed by the men. So the formula of this circle will not be applicable on the woman. Simply this first woman, how many options she have? 1, 2, 3, 4, 5 have. She have 5 options. Second, 4. Third, 3. 2, 1. It means 5 factorial. So 5 women can sit in 5 factorial ways, or you can write in this way: the 5 women can sit in 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. Again, that is equal to 5 factorial ways. So the total number of the arrangements is equal to 4 factorial into 5 factorial. Calculate is 2880. Only the group which will sit first in the circle, the formula of this circle arrangement is applicable on that group, and the second group simply it has to fill up the vacant spaces. Fill up the vacant spaces. This is a situation where the count is same. Count is same. Now, let us discuss. There's some here. It's here previous exam. First of all, let us see the question. Here is fourth A. The fourth B, I sent you the solution for this, but I think this topic we shall discuss in the next lecture. Okay. If it's not discussed today, then in the next, it is the principle of inclusion and exclusion. No, this is the numerical. If there are the 7 men and the 5 women, no, we change the situation, count of this. How many circular arrangements are possible in which women do not sit adjacent to each other? Same thing. Women, they do not want to sit adjacent to each other. Simply we have men, women, men, women, men, women. But no problem is count of men is more than the count of the women. No problem. Again we start the solution in the same manner. We have the 2 groups, men and the women. Number of the men 7 and number of the women 5. Here it is. Number of men 7, number of women 5. Women do not want to sit together. So, no. It is compulsory, first of all the 7 men. Say them, men, come and sit in a circle. Sit in a circle. So the formula of the circle is applicable on the men. 7 men can sit in circle is equal to 7 minus 1 factorial, that is equal to 6 factorial ways. This condition is clear. Here are the 7 men. M1, M2, M3, M4, M5, M6 and M7. But a new problem is created here. The women are 5. Women are 5. But vacant places are, how many vacant places? 1, 2, 3, 4, 5, 6 and 7. No, there are 7 vacant places. It means 5 women have to arrange into the 7 seats. Have to be arranged into the 7 seats. How? 5 women can be arranged in 7 seats is equal to 7 P5 NPR ways. Note here we write the same 5 factorial because in the previous case the vacant places were the 5 and the women were also 5. Now in this case women are 5 but vacant places are more than 5. So we use the formula NPR. 5 from the 7. 5 from the 7 ways. And the total number of the ways multiply both 6 factorial into 7 P5. I have made the calculations. Is this a total? It is the final answer. You can see, you will get this on your WhatsApp. You can see there also. That was the difference. The numerical was discussed in the class in the last session also, and it was in the exam. Yes, clear? No. Next, we'll see the topic combination. Combination means the selection. Combination means selection. One minute, please. If R objects are selected from the N objects, then the formula for combination, we write it Cn or in this way NCR is equal to N factorial divided by R factorial N minus R factorial. So that is the difference between NPR and NCR formula. Let us take this example, simple one, important one.
Sorry, please say again what is the difference between P and C?
P for the arrangements and C for the combination in selections. Let's say we discuss an example, simple. Again I repeat it. See, there is a class of the 20 students, 10 students in a class of the students. Some are wearing, everyone is wearing the different colored dress. Some are wearing black, some white shirt, some blue shirt, some red shirt. In this way, no. The teacher comes into the class and asks the students who are wearing the white shirts, they sit in the last chairs. They sit in the last chairs. Okay. Or he can say the students wearing the blue shirt, they sit in the front chairs. It is an arrangement. White shirts sit there, blue shirts sit there, red shirts sit on this side. The students are in the group. They are in the group. But for the selection, combination means selection. We see the same situation but in different manner. Teacher comes into the class and asks the students, hey students who are wearing white shirt, please come out. I will give you the gift. That is the difference. No, those students will come out of the group. And they will get the prize. They will get the prize from the teacher. Why? Because they are selected. They are only white shirts are selected for the gifts. Not blue, not red, not other colors. Okay, that is the difference between a simple arrangement and the selections. In selection, we pick up the objects from the group outside. But in arrangements, the objects are in the group. We only shuffle them. And this to that. Okay. Again, you will understand from this example also. It's an important example. You're welcome. No. How many different 7-person committee can be formed, each containing 3 women and 4 men, from a set of the 20 women and the 30 men? Say there is an office. In office, 20 women and the 30 men are on work. For the welfare of the employees, a committee is to be constituted of these 7 persons. Okay. In 7 persons, condition is that there should be 3 women and the 4 men. Remember, this is the condition. Men, women will be selected from the women. It's understood. And men will be selected from the men. You cannot select the men from the women or women from the men. Similarly, as we have written women and men, he can write here the batsmen and the bowlers. You have to make a team of the 11 players, 6 batsmen and the 5 bowlers. You have 20 batsmen and the 30 bowlers. Same condition here. Or some other condition also may appear. How many different 7 persons committee can be formed, each containing 3 women and the 4 men from a set of the 20 women and 30 men? First of all, we write the bifurcation, what's given into the numerical. Here women are 20, men are 30. Total 50. We are not concerned with the total. So what we have to do? We have to constitute the total members to be selected 7. See, selected 7. Selection means we will select the 3 men and 4 men from this group and make a committee. That is a separate. We could keep them outside the group. Keep them outside the group. Here it is a selection. Women to be selected 3 and men to be selected 4. One thing is clear. Women will be selected from the women. See here. You have the 20 women and you have to select 3 women. 3 women from the 20. 3 women can be selected in 20 C3 ways. Now it's a combination because it is a selection. You have to know, arrange them. We pick up the 3 women from the group, out of the group. Similarly, 4 men. 4 men can be selected from the 30 men. 4 men can be selected in 30 C4 ways. Yeah? The total number of the selection of the committee is equal to 7% is equal to, again, until the process is completed, multiply them. 20 C3 multiplied by 30 C4. See, for your knowledge, add these two figures. 20 plus 30 is equal to 50. And add this 3 plus 4, 7. From 50 you have selected the 7. Okay. This is the simple condition. That's important numerical. It's from your booklet. In next numerical, we will change the same situation. Let us see. It's also from the exam.
So, sir, we need not to multiply all those things and give total number. We have only give the formula. That means 20C3.
At home you can calculate it. It's you can you do it? I left the calculation for you. Okay.
It's a bigger number, no issue, but we need calculator also.
You can leave it here, but better calculate it. Try to calculate it. Otherwise, use the formula NCR. You will simply, very easily you can solve it. Solve it at home. Okay. Otherwise, I will help you in the next class.
Okay.
Tell me in the beginning. I will help you.
My concern is that in exam we have to give a total calculation number as well.
Yes.
Okay.
If by chance the figures are too large, cannot be calculated, and you have no time, then keep it there. You can leave that. Okay. same numerical, but we have changed the conditions. A committee of the 2 hawkers and the 3 shopkeepers. No. In place of the men and women, we have included hawkers and the shopkeepers. In a certain markets, we say the market want to make a committee of in which they include the 2 hawkers and the 3 shopkeepers. In a 5% committee is to be formed from a 7 hawkers and the 10 shopkeepers. In that market there are total 7 hawkers and the 10 shopkeepers. Find the number of ways in which this can be done. If the numerical was up to this, it is same as we discussed earlier, men and women. It means 2 hawkers from the 7 hawkers and the 3 shopkeepers from the 10 shopkeepers. Now numerical is finished. But this time some conditions are applied on this situation. Which one? See, if a particular shopkeeper is included and a particular hawker is excluded. What does it mean? In simple, while we have shop in the market, some hawker is very close to us. We say no, we will keep you into the committee. Okay. And one shopkeeper, we don't like him. We say at any cost we will not include him into the committee. This is a two situation, personal situation. One hawker is your favorite. We will keep him into the committee, and one shopkeeper, we don't like them. Sorry, shopkeeper is included, but one hawker, we don't like him. We say we will not at any cost include him. We will exclude him. Okay. Now, first of all, write the bifurcation. Hawkers are 7, shopkeepers are 10. Hawkers to be selected 2 and shopkeepers selected to be 3. But when no problem comes, a particular shopkeeper is included. It is our close friend. We say we will keep you into the committee. Got it? It means you have to select how many shopkeepers? 3. One is already in the committee. He is over very close to us. He is already in the committee. No. How many shopkeepers we will have to select? 2. We will select only 2. Third is our favorite. We will have to select the 2 shopkeepers from the 9. We say how the 9? Because 1 is our favorite. 10 minus 1 is equal to 9 and 3 minus 1 is equal to 2. 2 from the 9. If a particular shopkeeper is already in committee, then only 2 shopkeepers can be selected from the 10 minus 1 is equal to 9 shopkeepers in 9C2 ways. That is the change. No. Turn of the hawkers. We say a hawker is excluded. In these 7 hawkers, there is one hawker we don't like him. We don't want to keep into the committee. Cross his name. It means we have the 6 hawkers in the market. We don't count him, he is in the market. No, you have to select the 2 hawkers from the 6th one. Why? Because one hawker, we don't like him, we will not give him place into the committee. But we have to select the 2. It means we shall select the 2 hawkers from the 6th one, from the 6 hawkers. Yeah? So, this is a condition. If a particular hawker is excluded and the remaining are 6, now 2 hawkers are to be selected from the remaining 6 hawkers in 6 to C2 ways. In 6 to C2 ways. So the total numbers are 9C2 multiplied by 6C2. See, I will show the calculation. The situation is clear? Yes?
Yes.
Same condition can be added into the previous man or woman. final answer is the total number of the selection 9C2 multiplied by 6C2. We calculate in this way. I solved it completely 540 answer. Next, let's see. That is a Pascal triangle. One thing. Now this Pascal triangle is the replacement of the formula NCR. When there was no formula NCR, the solution for the NCR was by using this Pascal triangle. See, this numerical, use the Pascal triangle to find 7C3. 7C3. Remaining we shall calculate later on. We can calculate it by the formula NCR also, but here he wants to solve it by the Pascal triangle. How to construct the Pascal triangle? This number is 7. This number is 7. So we have to make 8-floor pyramid. It's 8-floor pyramid. Count it. From top to bottom. 1, 2, 3, 4, 5, 6, 7 and 8. Like this, write 1 here. Start from here, where it is cursor. Write 1, then 1 on left and 1 on right. Expand the basement every time. Expand the basement. No. For the third floor, from top to bottom, write 1 and 1. So add 1 plus 1 is equal to 2. Here write 1 and write 1. So for the fourth floor, 1 plus 2, 3. 2 plus 1, 3. Write 1 and 1 here. Always when you go to the lower floor, expand the basement. Expand the basement. Basement is made of the 1, 1. These are the walls. These are the 1, 1. They are the walls. Okay. They only help in making the Pascal triangle. They have no role in the calculation of the NCR. Next, 1 plus 3, 4. 3 plus 3, 6. Write between the two numbers. 3 plus 1, 4. And both sides 1 and 1. It's the 5th floor. Then 6th floor, 1 plus, from top to bottom we are moving. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And 1 and 1 on both sides. 1 and 1 on the both sides. Every time when we come to the lower floor, expand the basement. No, see, 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. And 1 and 1. So, last floor. How do you come to know it's the last floor? Because at top it is 7. 7 plus 1 is equal to 8. We make the 8 floors. 1, 2, 3, 4, 5, 6, 7 and this is 8. 1 plus 6, 7. 6 plus 15, 26. Now, these red circles, they are the solution of this. They are solution of this one. Then 15 and 20, 35. 20, 15, 35. 15, 6, 21. 6 plus 1, 7. And 1 and 1. It is the Pascal triangle. It is the Pascal triangle. This value tells us how many floors will be there. No. How to find 7C3? How to find 7C3? Let's come to the triangle. Where is 7? Here it is 7. Here it is 7. From counted 1. It is 2 and it is 3 and it is 3. And answer is 35. 7, 3, C3, 35. If you use the formula, answer will be same. Okay. So say 7 it is first, it is second and it is the third. Similarly, if 6C2, it is 6, 1 and 2, 6C2, 15. 5C4, ये 5, 1, start from here, 1, 2, 3, 4. 5C4. That is a Pascal triangle, and with the help of Pascal triangle, we can solve the combinations.
Sir, repeat 6C2 and
Yes.
5C4.
Again repeat. Yes. What do you want? We should repeat. Okay. So again I say, what he says, use the Pascal triangle. The written here is in the Pascal triangle to calculate 7C3, 6C2 and 5C4. You can calculate it also by formula NCR, but we want it to be calculated by using Pascal triangle. How to make the Pascal triangle? First of all, see here, the value here, it is 7 is the largest value. 7 is the largest value. Okay. So you will make the 8 floor pyramid. One more. 7 plus 1, 8. 8 floor pyramid. Count it. 1, 2, 3, 4, 5, 6, 7 and 8 floor pyramid. How to make this pyramid? We start from the top. We move from top to the bottom. Write here 1. Take a pen and paper. Write 1 here. Then 1 and 1. How they are written? By expanding the basement. One slightly on the left and this one slightly on the right to this. Now add both. 1 plus 1, 2. 1 plus 1, 2. Now see 2. Now, right here 1 and here 1. It is a third floor. Now add 1 plus 2, 3. 2 plus 1, 3. No. write one here and one here. Every time slightly left on the left, slightly on the left, and of right, slightly to the right. Go add it. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Yes. And 1 and 1. Every time starting 1 and closing 1. Again write 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Again and write 1 here and 1 here. Expand the basement every time. No, again add 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. 1 here and 1 here.
Sir, if you want to calculate 7C4, then the answer will be same 35?
Yes.
7C4?
Yes. You will encircle this.
Yes, sir.
Also, okay.
7C3 and 7C4 are same.
They will be same. You can check by calculating NCR, formula NCR.
Yes.
See.
And sir, more than seven combination.
If it is 8, then increase the one more basement.
Okay, got it. So there is no finite limitation of this, right?
There is no limitation there. Okay. Every time these expand this. These one they have no role in the calculation. They are the only walls of the pyramid. They are only walls of the pyramid. Okay.
Sir, we may count either from left or right.
7C4.
Yes. Only
7C4.
7C4. They count in this way. Here it is. Keep your cursor here. It is 7. From here count 1, 2, 3 and 4. Encircle it. It is 7C4. Again 35.
We may start from left or right, na? Either left or right.
From left to right. Always from left to right. Keep this pattern. From left to right.
Okay.
If you want to 5C3, say 5C3. Here it is 5. Count 5 as a 1, 2 and 3. It is 10. And 5C2 is also 10. Okay. Now the faster time without using the formula, you can find the value. Let's see again. Sometimes these are the algebraic numericals. Through this result, see, it's pure algebra. It is also called the Pascal formula. It is also called the Pascal formula. N plus 1 CR is equal to N CR minus 1 plus NCR. So everyone, you I think know about the factorials. Yes. In factorial, we can calculate the factorial like this. Say, we remove the last member. if it is the 5 factorial, say if it is the 5 factorial, what is the meaning of 5 factorial? 5 factorial means 5 multiplied by 2 multiplied by 3 multiplied by 1.
2.
If we remove the 5, then how many factorials are left? 4 factorial. It means from the line, remove the last member. From the line, remove the last member. If it is 10 factorial, we keep the 10 outside the factorial, the remaining are the 9 factorial. So we have to prove this result algebraically. Simple. Expand the formula on the both sides and calculate the factorials. Cancel the factorials. Like this. See, formula is NCR formula is n factorial divided by r factorial n minus r factorial. It is n plus 1 factorial, r factorial, n plus 1 minus r factorial. Okay. Now expand this formula, n factorial divided by r minus 1 factorial into n minus r plus 1 factorial. NCR is equal to n factorial divided by r factorial n minus r factorial. We have applied this formula here and here also. We want to get rid of the factorials, then we can calculate the algebra. How to get rid of this factorials in this way? Convert the larger factorials into the smaller ones. Convert the larger into the smaller, like this. N plus 1 is larger and n is smaller. How much smaller? Here it is 1 is more. Here it is 1 is more. So, in this next step, see, keep n plus 1 outside and remaining are n factorial. Okay. And on the right hand side, take n factorial common. And from the both sides, n factorial cancels each other. Now, see on the denominator, here it is r factorial, r minus 1 factorial and r factorial. In all these three members, r minus 1 is smaller and r is factorial. R factorial is a larger. So always convert the larger into the smaller ones. From r factorial, take r outside, remaining are r minus 1 factorial. Here, r minus 1 factorial as it is plus. From here, take r outside and remaining are r minus 1 factorial. And it is n minus r factorial. So in next step, you can take r minus 1 factorial common from the right hand side. So it is n plus 1 factorial, n plus 1 divided by r into r minus 1 factorial. On right hand side, 1 upon r minus 1 factorial common. The remaining are 1 upon n minus r plus 1. Sorry, n minus r plus 1 is also calculated. First of all, r minus 1 factorial common. So this cancels on the left and right hand side. No, this is n minus r plus 1. It is n minus r plus 1 and it is n minus r. These both are one more than this. So take n minus r plus 1 common outside. Remaining is n minus r factorial. Similarly here, n minus r plus 1 outside, remaining n minus r. Here it is n minus r factorial. Now next time, take n minus r factorial common. Take n minus r factorial common. N minus r factorial common. It is 1 upon n minus r plus 1 upon r. ये आ जाएगा. No, n minus r is factorial cancels on the both sides. The remaining things are It is algebra. It is purely algebra. C on the left side, it is n plus 1 divided by r into n minus r plus 1. Here, take LCM, n minus r plus 1 into r. It will become r plus n minus r plus 1. This bracket cancel with this, r factorial with this, r with r. N plus 1 is equal to n plus 1, cancels, 1 is equal to 1. Therefore, left hand side is equal to right hand. Sometimes these algebraical formations, they also put into the exams. Let us see one more example. This one. Yes. Also from the exam. 19. Yes. That's somewhat difficult also. See, it is the equation 100C98 is equal to 999.97 plus x 901. Find the value of x. Find the value of x. In this numerical, some basic results, they will be used. When we will use them, I will make a note down separately. They help in the calculation of the factorials. So, first of all, simple algebra, you have to calculate x. Keep x on the left hand side and all the things on the right hand side. XC901 is equal to 1000C98 minus 999C97. We say the calculations are too big. How will you calculate? We will use the basic concepts to calculate. Simply from the given, we keep x on one side and the remaining on the other side, like in the algebra. We have to calculate the value of the x. No, simply apply the formula NCR. NCR here we apply x factorial divided by 901 factorial x minus 901 factorial. N factorial divided by r factorial multiplied by n minus r factorial. Same formula. Similarly on right hand side, (1000) factorial divided by 98 factorial into 1000 minus 98 factorial minus 909 factorial divided by 97 factorial into 900 minus 97 factorial. Formula of NCR. Use the formula of NCR. The calculations are getting typical and typical. Why? Until or unless we use the basic formulas, they will not show us the answer. See on the right hand side, left hand side, there is nothing to do. Here again, 1000 is larger, 999 is smaller. Keep 1000 outside, remaining you get 999 factorial. Similarly, 999 factorial divided by C here, 1000 minus 98 is equal to 902. And for 98 factorial, the formula will be 98 into 97 factorial. Then 999 factorial divided by 97 factorial. इसे कैलकुलेट करेंगे 902 factorial. From both, we take 999 factorial, 97 factorial, and 902 factorial as a common from the both sides. So bracket में what is left in the bracket, that is equal to 1000 divided by 98 minus 1 that is equal to 999 factorial divided by 97 factorial. 902 factorial, ये मल्टीप्लाई का साइन है. 1000 minus 98 is 992 divided by 98 factorial. यहाँ तक ये कैलकुलेशन. देखो इसे आप थोड़ा हार्ड है, अलजेब्रिक प्रॉब्लम सबकी हार्ड होती हैं. अभी 2 मिनट में करवा रहा हूँ. इसके बाद इन्हें देखो आप. हेलो, सॉरी स्टूडेंट्स, मैं 2 मिनट के लिए चला गया था. हेलो
Hello, sir.
Okay.
के लिए मैं बाथरूम चला गया था, तो लेट्स रिपीट इट अगेन. You take the common 999 factorial divided by 97 factorial and 902 factorial common here. The remaining it is 1000 divided by 98 and minus 1. All this factor is outside. Now calculate this one. You will get 902 divided by 98. Here it is a reverse process, like this. You send the 98 inside the 97 factorial. It will become 98 factorial. It will become 98 factorial. Okay. Then from 992 factorial, keep 902 outside. The remaining it will become 901 factorial. So that 901 factorial cancels with 901 factorial. The remaining equation is left x upon x factorial divided by x minus 901 factorial, that is equal to 999 factorial divided by 98 factorials. In the factorials, the theorem says if the two factorials are equal, then their numerator is equal to the numerator and denominator is equal to the denominator, like this. X minus 9 factorial is equal to 98 factorial. You can write also this x factorial is equal to 999 factorial. Second theorem says if a factorial is equal to b factorial, then a is equal to b. If a factorial is equal to b factorial, then a is equal to b. By using this theorem, we use x minus 901 is equal to 98 and x is equal to 999. That is a complete solution.
Sir, 97 factorial.
97 factorial, here send 98 into this factorial, it will become 98 factorial. Clear?
Yes, sir.
Okay, sir.
As we
सर ये फैक्टोरियल भी कट जाता है एक दूसरे का ऑपोजिट में जो होता है.
yes.
अच्छा.
Yes, ये थ्योरम होती है.
तब तो ये सॉल्व हो गया.
ये आंसर. Sometimes these are the basics of the permutations and combinations. All the things which you are doing, they are from your booklets, written in your booklets. The difference is that the solutions are very in a shortcut. Now see the numerical, it's also from your booklet. Either from your booklets or from your exams. And mostly the same numericals, they will appear into the exams. An urn contains 15 balls, urn means bag. A bag contains 15 balls, 8 of which are red and 7 are black. In how many ways can 7 balls be chosen so that at least 5 are red? Here the situation is changed at least, or sometimes at most they change the total situation. And write the bifurcation. We have 8 red balls and the 7 black balls, total 15. We have to select the 7 balls. We have to select the 7 balls in which at least 5 are red. No, problem is here. At least 5. But 5 are 8. 5 are 8. It means you can select 5 red. You can select 6 red, or you can select 7 reds, because there should be at least 5 red. Okay. You can choose also 7 red. not 8 because you have to select only 7 balls. No, we make the different conditions. In the beginning, as we were discussing that we were multiplying all the situations, 26 by 26. That was the multiply theorem. Now, when we use the addition, then the same process is done in different ways, like this. In the first case, we make the table a red and black. If we select the 5 red, then we will have to select the 2 black balls. Okay? Why? We have to select the 7 balls. So if we select the 6 reds, then we have to select the 1 black ball. Or if we select all the 7 reds, then no need to select any black ball. So there are the 3 situations. 1, 2, 3. In every situation, see 7, 7, 7. Now calculate all the 3 situations and add them. That is the addition theorem. From the first case, you see, in the first case, 5 red and the 2 black balls can be selected in. Again say, red from the red and the black from the red. Black from the black. 5 red from the 8. 8 C5. And the 2 black from the 7 black. 7 C2 and 7 C2. In the second case, 6 red and the 1 black ball. 6 red means 8 C6 multiplied by 7 C1. 8 6 6 multiplied by 7 C1. In the third case, 7 red, no black. 7 red means 8 C7. From 8 you have to select the 7 red into 8 C7. So, in every case you see the different conditions are multiplied. But in total options, total number of the selection, it is case 1 plus case 2 plus case 3. It is sign of plus. Okay. Because one situation we can do in the 3 cases. So we add all the 3 cases. You can leave the answer here in this case. Here it is plus. Leave the answer in this way. If you have no time to calculate, for practice you can calculate at home. Yes, clear?
Yes, sir.
Yes, sir.
Now the different situation comes. As we were discussing into the permutations, with repetition, with no repetition. But we never used this statement in the case of the combination. Still we did not use it. Okay? Because as many as situations we discussed in the combinations, they were without repetition. The repetition. Now what will happen if we allow the repetition? Then the formula of NCR will change. So in combination, also remember the possibility of repetition and without repetition. If it is written without repetition, if nothing is written, then it is without repetition. If it is written with repetition, then the formula is same. Let us see. No, if R objects with the repetition are selected from the N objects, this is the change. Then the formula is C N plus. There is something wrong. Don't use it. It is a formula. Again, there is formula something else. The formula is, write this formula. Forget it. Cn plus r minus 1 comma r. We use this formula when the repetition is allowed. Let us say this example. In how many ways can a prize winner choose 3 books from a list of 10 bestsellers if repeats are allowed? If repeats are allowed. Repeats are allowed means if you can select all the 3 books of the same subject. So here, total number of the books n is equal to 10, and to be selected, they are 3. Since the repetition is allowed, therefore the total number of the books selection with repetition, the formula will be C n plus r minus 1 comma r. N is equal to 10, r is equal to 3 minus 1, r is equal to 3. It means C12 3 calculated, that is equal to 220. Answer is 220. Simple numerical, but with repetition. If you use the previous formula, the answer will be wrong. The previous formula was when the repetition was not allowed. One more. Yes. This numerical was in previous exams. Same numerical there was in last exam. I have sent that PDF to you. Its worth was 4 marks. Same numerical. It was there. Find the number of the integral solution to the equation x1 plus x2 plus x3 plus x4 is equal to 7. First, understand it. What does it mean? If you add the 4 integers, then their total is 7. Like this. 1 plus 1, 2, 2 plus 2, 4, 4 plus 3, 7. 4 integers. Similarly, 3 plus 2 plus 1 again 7. So there are so many ways. The sum of the 4 integers is equal to this 7. Like this, minus 2 plus 5 plus 3 plus 1 again equal to 7. Integer means it may be positive or negative. It means the repetition is allowed. So, please close the mic. Switch off your mics. It tells us that the sum of the 4 integers is equal to 7 in different ways. 1 plus 1 plus 1 plus 4 is equal to 7. 2 plus 2 plus 2 plus 1 is equal to 7. It means repetition is allowed. Repetition is allowed. It is the first numerical you will see in which n is smaller than the r. It appears. But why it is so? Here the repetition is allowed. So they can be repeated. N is equal to 4. Number of integers there are 4 and r is equal to 7. Now in this case, if you apply the old formula, the factorial will be into the negative, and all the meaning of the factorials will be non-defined. So the total number of the solution, we use this formula C n plus r minus 1 comma r. N is equal to 4, r is equal to 7, minus 1, R is equal to 7, C 10, 7, calculated 120. Okay. This numerical it was in your previous exam.
Sir, why we have added n plus r?
It is formula. When repetition is used, this formula is used in place of C and R. Okay.
Okay, got it. For repetition concept, we use this type of formula.
No. When the repetition of the objects is allowed.
Okay.
Here repetition is allowed.
Okay.
See, 1 plus 1 plus 1 plus 4 is equal to 7. 1 is repeated 3 times. It means these integers are repeatedly. If the objects are repeated, then we use this formula in place of C and R.
Okay, and when it will be not repeated, then what would be the formula for that?
Then C and R. Then C and R. The previous which we discussing.
Okay.
This numerical was in your previous exam. From the question paper, you see the numerical and it is the answer. You can note the answer from here.
In the question, it is not mentioned like the value can be repeated. So, do we need to assume that every time?
Yes. Yes. Repeat what you want to say.
Like in the question, it is not mentioned like the values can be repeated. So, do we need to assume this every time?
Okay, when it is repeated, we don't assume when. Here it is not clear, but it is our IQ from where we decided. That was the worth of the numerical. In the previous numerical, it was repeated. It was written. Repeats are allowed. Sometimes the situation or the condition itself tells us that the repetition is allowed. Let us see one more example. It will clear all these things. See, a student, it's also from your booklet, this one. A student in a hostel is allowed 4 fruits per day. In a student in a hostel, whenever she or he goes for the lunch or the dinner, she is allowed the 4 fruits. 4 fruits per day. There are 6 different types of the fruits from which she can choose what she wants. Now this language tells us the repeats are allowed. She can select 4 apples, she can select 4 bananas, she can select 4 any other fruits. Okay? So here the language itself tells us the repeats are allowed. Simply from the 6 fruits, a student has to select the 4 fruits per day when the repeats are allowed. When the repeats are allowed, simple. What she wants, for how many days she makes the different selection. Simply, total number of the fruits 6 to be selected for with repetition. Who told us? This language told us she can choose what she wants. So we use the formula, the number of ways of selection C, 10 plus R minus 1 comma R. Put the value n is equal to 6, R is equal to 4, minus 1, R is equal to 4, then calculated 106.26 takes. It's from your booklet. So, next time we will start the new.
Hello, sir.
Yes.
Sir, in last question, how we have taken R is equal to 7?
their total is 7. Here it is R. It could be the sum of the 4 integers. It may be 1, 2, 3, 4, 5, 7, 100, anyone. So it is R. And number of integers, they are 4. Okay, this total is R. Here.
Okay. So numbers we can choose from 0 to 9.
No, from 1 to so on, not 0 from 1. There are the integers. Integer means plus and negative. So it like this also, -1, -1, -1. It is -3. -3 plus 10 again equal to 7. Again equal to 7. Though there are so many ways we are calculating, there are 120 ways.
Yes, sir.
Okay, so also note this. Just take the screenshot from this also. All these are important ones. It's okay. So time is over, I think. Huh? Okay, we will discuss the next time. Oh, just a minute. Problem is there is limited time to discuss the whole syllabus. So the time is very less. Okay, we shall discuss in the next lecture. It's okay for today. Have a good day, students.
Sir,
Thank you, sir.
Thank you and welcome.
Thank you, sir. Thank you,
Sir, you have taken the attendance?
Yes. Think about the attendance. Whenever you enter into the class, your attendance is there.
this is the good way.
Thank you, sir.
Don't worry about your attendance.
Thank you, sir.
Okay. You next time, friends.